Hi, I'm Dr. Sheila Mitchell, and today we're going to talk about building better training through cognitive task analysis. We're going to address why the status quo isn't working, why the knowledge you're capturing is incomplete, and the ways to capture the knowledge a more complete knowledge picture. Cognitive task analysis is a general name for a variety of techniques that are used to elicit the information, knowledge, and methods of performing a given task from experts. As an extension of time and motion studies of manual labor, cognitive task analysis addresses an observable action by determining the procedural and declarative knowledge, decision points, and strategies necessary for that task's completion. This knowledge is then available to be used for business continuity or to create training. Training based on cognitive task analysis is better for students because they are, in fact, getting the full picture. They are getting a fine-grained introduction into the expert's thought process. And this eliminates the struggle to fill in the gaps when students are dealing with the normal mode of training. This is important for businesses because in a lot of cases, critical operations are performed by experts. And brings up the question, what do you do when the expert's not there? As I said, CTA is used for pulling information from those experts. Although it's possible to use CTA for simple tasks, it's really unnecessary. CTA instead is ideal for training that is widespread or scaled to your whole organization, such as when training is addressing a large, complicated new HR policy. It's also ideal for when the content deals with circumstances where mistakes can be costly, such as working with large batches or expensive raw materials. It's well suited for when the tasks are safety critical, such as operating heavy machinery or many jobs in the oil and gas industry. And the training is excellent for when it has to be, and it's excellent for training that has to be as quick and efficient as possible. If a traditional training module lasts several months, you may be able to trim the time down by using cognitive task analysis and still get the learning gains that you need. Cognitive task analysis facilitates knowledge acquisition from your experts. In typical interview forums, experts can omit up to 70% of the decisions that they make. That's 70% of your process that may impact safety, quality, or efficiency. Why do they leave out so much? Well, it's really the way memory works. When dealing with expertise, your primary memory constructs that you're worried about are working memory, long-term memory, and schemas. Working memory is your focus, your attention, or your consciousness. It's also where you manipulate information to learn or to perform tasks. It's extremely limited, probably between 3 and 5 slots, and the unlearned content in there can fade with time if it's not rehearsed. This is important. You only have 3 to 5 slots to hold everything necessary for performing a task. So how do we get anything done at all? Well, one way is by chunking, which is a way to expand working memory. Chunks take up only a single slot in working memory, and they vary in how much information they hold. For example, if most Americans are given 6 letters FBI, CIA to remember, they'll reduce it to 2 known and easy to remember chunks, FBI and CIA. Or think about a chessboard at the starting position. For someone who doesn't play chess, trying to absorb all the information about the number of pieces, their shapes, their locations, their colors, that's all very difficult. But for a veteran player, that's a single chunk, and it only takes a single slot in working memory. Once information is learned, it's stored in long-term memory, which essentially has an unlimited storage capacity. However, while information is stored in long-term memory, you're not conscious of it until you pull it into working memory. All that knowledge not only has to be stored, it has to be stored in a logical and retrievable manner. That brings us to schemas. Schemas are hierarchical memory structures that hold a person's knowledge and take up only a single slot in working memory. More complex and better elaborated schemas contain and integrate more information into a single chunk that can be used to recognize and retain knowledge in meaningful ways. You get those schemas through learning and through practice. Consider the example of reading. The very complex schema for reading allows us not only to recognize letters, words, and phrases, but it also allows us to read different fonts and most handwriting with all that variability. This schema has been constructed and modified with years of learning, and if all that information existed as individual elements, it would overwhelm your working memory. But stored as a schema, it can be pulled into working memory and still only take a single slot. The schemas stay in working memory until they are needed, and then they're pulled into working memory. And the whole complicated, as I said, the whole complicated schema takes up just one slot. This is really important to remember. After extensive practice, a schema can become automated so that the familiar tasks are performed accurately and fluidly, directly from long-term memory without occupying any space in working memory. This frees valuable working memory to address other things, which is one of the features of expertise. So let's look at experts and what makes them different. The concepts of expert and expertise are nebulous and have no one right definition. There are, however, recurring traits or characteristics that describe experts and expert performance, particularly in relation to novices. First, experts tend to excel primarily within their own domain. Typically, they aren't all-around geniuses. For example, medical expertise does not automatically transfer to architectural expertise. The expert has superior domain knowledge, not necessarily superior thinking. Experts can perceive large patterns and make interconnections within their domain, primarily because of the way their knowledge is organized and not because of their perceptual ability. Given a set of circumstances, the expert can perceive a variety of stimuli, recognize it as a pattern, and because they understand what it means in their domain, they can use this pattern recognition to process huge amounts of information, often very subtle. And sometimes it gives the impression to other people that they have an intuition about their domain. Experts also perceive and understand their field in a deeper and more principled level. For example, an expert and a novice could be given a physics problem with a block on an inclined plane. The expert will call it a mechanics problem using conservation of energy and the Newtonian force laws. The novice, however, calls it an inclined plane problem. The expert understands what it is and what it takes to solve the problem and where this information lies in the grand scheme of things. The novice, however, just describes it using superficial details. And next, when a task or problem is given to an expert, they will spend a substantial amount of time qualitatively analyzing it before they develop a solution. Here, they'll question their understanding of the problem features and attempt to make sense of it. They'll create a mental model that includes complex relationships and constraints. After the mental model, however, experts reach a solution faster and with fewer errors than novices. This speed stems from practice or experience that allows more mental resources and possibly the ability to have recognized the problem from having seen it in the past. An expert also self-monitors. They can tell when they've made a mistake, and they can also foresee how complex a problem is and how long it'll take them to solve it. Finally, experts limit the solution set where they search. This is because of their experience and their earlier analysis. That's where cognitive task analysis comes in. Through a variety of techniques, you eventually pull those automated schemas into working memory, and your expert can give you a fuller representation of what they do, where they decide something, and how they perform it. This is an overview of the process, which we'll give in greater detail next time. First, you collect preliminary knowledge. To do so, you need to have a basic understanding of what the process is and the terminology used. From there, you develop a detailed account of how the expert performs the process. Most techniques stop here, but as we have learned, those results are incomplete. You then create a knowledge representation of the task. This could be a flow chart, a series of if-then statements, a concept map, or any other representation that's suitable. Third, you'll need to ask the expert a long series of questions. The information you're trying to gather includes the sequence of the steps, the information required for each step, the time the step takes, and what is the necessary knowledge for the step and its quality measures. After that, you analyze and verify the process. This means making some sense and some sort of functional map that from which you try to recreate your expert's results. You look for holes or sequence problems, and if you have a second expert to bring in, that's even better. Once complete, you can now format the knowledge for use. I've talked a lot about the interview techniques and such, so let's see how they actually play out. These interviews generally follow some pretty standard formats. There's informal observation in interviews. These allow flexibility. There's process tracing, where the expert is given a task and performance is analyzed by recall or think aloud. There are conceptual techniques. This is a tightly structured method that provides a formal knowledge representation of a domain, such as card sorting tasks. Those are more often seen in academia. There's also formal models where software simulation attempts to replicate the expert's performance. Again, often seen, or most often seen in academia. Next time, we'll discuss some specific methods for cognitive task analysis and go into more of the nuts and bolts. We'll talk about the techniques that I found to be helpful in interviewing experts. These methods can be helpful in interrupting the automated processes, therefore bringing the information into working memory. This will allow experts to be conscious of and express what they do from those automated schemas. Do we have any questions?
Well, thank you, Dr. Mitchell, for that great presentation. Okay, let's open up the lines for a live Q&A right now. If you have a question, you can simply type it into the chat. Okay, our first question came in to the chat. It says here, I'm gonna read this. I'm gonna go ahead and read them out to you, Sheila.
Okay.
Is this really worth the cost?
Well, it depends. If it's something simple, no, it's not worth the cost. It's overkill. If it's complicated, if it's safety sensitive, if it's critical, that's when you start really, it starts really being worth the investment. When you deal with medicine, large batches, manufacturing in time critical constraints, all these sort of tasks are better suited for cognitive task analysis than a simple assembly line process. So it can be very much worth the cost, but not for just any task.
Okay, thank you, Dr. Mitchell. Let's see, here's another question here in the chat. It says here that I've heard that it takes 10,000 hours to make an expert. Is that true?
Not necessarily, and the converse is also not true. It doesn't mean that if you practice 10,000 hours, you'll be an expert. And to become an expert doesn't necessarily take 10,000 hours. Malcolm Gladwell mentioned the 10,000 hour, as he called it, the 10,000 hour rule in one of his books, and I can't remember which one it was, but he was citing Anders Ericsson about his work when he had studied, when Ericsson had studied violinists. And Ericsson had said that there were some violinists who took up to 10,000 hours to become experts. But he didn't mean that as a rule. He meant that as just a comment. It was really a throwaway comment. And there were some experts who had become expert with as little as 4,000 hours. It's really not the hours of practice. It's really about the type of practice. It has to be a very deliberate, very precise, repetitive, very strenuous practice that you do to build expertise. And yes, Ericsson has disavowed the 10,000 hour rule.
Okay, great. Thank you. Let's go ahead and do one more question. I see one more here in the chat. It says, has this been successful?
Yes, it's been very successful. A lot of the applications of CTA are in the military, and that's not information we generally have access to. So the other place that is really common to use is in medical education. They did a study, some gentlemen did a study with nurses, neonatal intensive care unit nurses. They were looking at respiratory illnesses. And they asked the nurses, when was a time that you've made an impact on an infant's life? And talking about respiratory illnesses. And the nurses came up with these events. And when they asked them, what were the cues that told you the infant was about to go into respiratory distress? And repeatedly, the nurses all gave the same set of like 6 or 8 answers that were literally from the textbook. And when they started talking to the nurses and started delving more into what actually happened and pulling the information out of them, they actually discovered another set of maybe like 12 or 15 cues that these nurses, many of them repeating the same cues, what would be considered cues for infants going into respiratory distress. So in essence, and actually in reality, they were literally able to rewrite the book just by doing the study on cognitive task analysis on nurses.
Okay, thank you, Dr. Sheila Mitchell. This is all the questions that we have time for today. You will be able to find a link to this recording and a copy of the slide deck on our radiant.digital website very soon. The conclusion to this cognitive task analysis series will be in 2 weeks from today on November the 11th at 1 p.m. Central Time. And again, I'd like to thank everybody in the audience for joining us. And of course, thank you to Dr. Sheila Mitchell.